Hello folks, I am Ayushpat and today on behalf of AWS Cloud Community LPU, I will discuss key management service and we will see through AWS Lambda how we can use KMS to encrypt and decrypt secrets. So let's get started. We will search for the key management service. And we'll go to the KMS console. AWS KMS is an encryption and a key management service. But this service we can easily manage and securely store our keys. What the benefits of these services are that AWS KMS keys are used by other AWS services like Amazon Aurora, Amazon EFS, EKS and many more. And you can use them to protect data in your own applications that use AWS. Before starting to the KMS service, we must understand the key hierarchy that is being followed. In AWS KMS, key hierarchy starts with a customer master key, and we can use this customer master key to directly encrypt data blocks up to 4 KB, or it can be used to secure data keys. And data keys are used to protect data of any size. So in data keys, we don't have any restrictions about the data size. Customer master key are also called CMK. Now CMK can be broken down into two general types, AWS managed and customer managed. First we will see what are the AWS managed CMK. So as we can see, there are several keys. AWS managed CMK can only be used to protect resources within the specific AWS service for which it is created. Like here we can see that this key ID belongs to this service. So like we can see that it says that the default master key that protects my EBS volumes when no other key is defined. Means that this master key protects the EBS volumes. Similarly, we can see other keys here, like this is the alias name, and here we can see that this master key protects backup data when no other key is defined. So these are the several AWS managed key. Now moving to the customer managed keys. It is a best practice considered to use customer managed CMK in all supported AWS services as well in your applications. Here I have already created a key and this shows the status of that key. So now I will go and create a new key. So first we have to select a key type. So symmetric keys are used in symmetric encryption, where the same key is used for encryption and decryption. Also, symmetric keys represents a 256-bit encryption key. If your use case require encrypting and decrypting data, the symmetric encryption algorithm that AWS KMS uses is fast and efficient for this purpose. Now if I go and select the asymmetric key of key type, in this key type two keys are used, public key and private key pair, that you can use for encryption and decryption. You might be wondering where we can use this key type. Let's consider a scenario. If you have a use case that requires encryption outside of AWS by users who cannot call AWS KMS service, there we can use asymmetric KMS services. Now let's see the key usage. First is encrypt and decrypt. What happens in this is we can share the public key of the asymmetric KMS key to allow specific users to encrypt data, and our application that needs to decrypt that data uses the private key of the asymmetric KMS key. Other one is the sign and verify. This uses the private key for signing and public key for the verification purpose. Now we will see the key spec. This represents the cryptographic configuration of your KMS key. For RSA key specs, can be used for encryption and decryption or for signing and verification purposes. Whereas the asymmetric NIST recommended elliptic curve key pairs are used for the signing and verification purpose. Also, there is another option ECC-SECG-P256K1, and this key type is commonly used for cryptocurrency. For our current demo, I will select symmetric key type. In the advanced options, we will see key material origin. First one is KMS. AWS KMS creates and manages the key material for the KMS key in its own key store. So we don't have to worry about the key material. The other option is the external. Second option is external. In this, what happens is when you create a KMS key with external key material origin, the KMS key has no key material, and we have to import key material into the KMS key later in custom key store. In custom key store, what happens is that the AWS KMS creates the key material for the KMS key from the custom key store, that is the cloud HSM. For this demo, we'll be using the KMS as the key material origin. Now we will discuss about regionality. Like it is written that we cannot change this setting after the key is created. Like we cannot change the regionality. So what is regionality? That is, first option is the single region key. So in single region key does not allow key to be replicated into other regions, whereas in multi-region key provides more flexibility and data security. It allows the key to be replicated from one AWS region into another. With multi-region keys, we can easily move encrypted data between the regions without having to decrypt and re-encrypt with different keys in each region. So this also helps in the management purposes. Now we will for this demo we'll be selecting the single region key and going to the next. Now we will give the friendly name to the AWS KMS key. We will name it as demo KMS. You can also give the description, it is optional. We can also add the tags that help us to categorize and identify our KMS keys, and also it helps you to track your AWS costs that are associated with these keys. We will name it as key1 for demo and select the next. Now we have to define the key administrative permission. This feature allows us to choose IAM users and roles in the account and make them as key administrators. One point to note here is that key administrator have the permission to manage the KMS key, but do not have the permission to use the KMS key in cryptographic operations. Like the cryptographic operations are the API operations that use KMS keys to protect the data. So for now I am not going to select this option. Now the key deletion feature. It allows the key administrator to delete this key so that we can easily delete this key. Now here is the define key usage permissions. We can select IAM users and roles that can use the KMS key in the cryptographic operations. Here also we can add other AWS accounts that can use this key. For now I don't need. Now we can review the key configurations and click on the finish button. Here is the key created, demo KMS, and this is the Amazon resource name associated with this key. Later on we will need this ARN. Now we will go to the AWS Lambda function. As in AWS Lambda, we can run the code without thinking about the servers. So like here we don't need to worry about which AWS resources to launch or how we will manage. All of this is taken care by the AWS Lambda. Here we will first create a function. Now we will hear some basic information. What's the function name? So we will keep it as function demo1, function demo KMS. We'll select the runtime as Python 3.7. The architecture feature is here. This determines the type of computer processor that Lambda uses to run the function. Now we will keep it as default. So like this is our lambda function.py Python file. Here what we are going to do is we are going to encrypt and decrypt the secrets. This secret can be of any database. So we will go to the configuration in environment variable, and here we will edit. So here we will add the environment variable key value pair. So the key will be let's say db password, and we'll keep its value super secret. Here we can see that this value is easily visible. So now we have to encrypt this value. So let's see how we can do this. In encryption configuration that are provided in AWS Lambda. For this we have to understand some vocabulary, like what is data in transit or data in motion. So this is the data moving from one location to another, such as across the internet or through a private network. Here we can see an option for encryption in transit. So encryption in transit is the protection of this data while it's traveling from one network to another or being transferred from a local storage device to a cloud storage device. So we will click it, and as soon as we click it, an option for encryption in transit with encryption button appears. Now the second field is AWS KMS key to encrypt at rest. So to understand encryption at rest, let us understand it with an example. Let's suppose I saved a copy of paid invoice on my server with the customer credit card information. Now this information is very critical and I don't want it to fall into the wrong hands. By encrypting data at rest, customer sensitive data is being converted into another form of data. I can say a more secured form of data that can't be decrypted by any unauthorized users. So here for that purpose I'll be using a customer master key. As soon as I click it, there are two keys appearing. I will choose the demo KMS that I have created earlier, and there is also one option to encrypt in transition appears. Now we will click on this encrypt button. So here it provides us the decrypt secret snippet, so we can use this snippet in our code. So first we could so let's copy this. So here we can provide the AWS KMS key to encrypt in transit. So we will use the demo KMS key secret snippet, which we can use in our code. I have copied it. Now let's encrypt. Now we can see that the value has been encrypted. I will save it. Now we can see that nobody will be able to see what is the value of this. db password key. We'll go to the code and paste the code that we have copied. Now let us little bit understand this code. The import Boto 3 is the Python SDK for AWS, and this allows us to directly create, update and delete AWS resources from your Python scripts. The OS module provides functions for interacting with operating systems. The B64 decode function from the base64 module in Python is a function that from which we can decode the binary string into normal form. Here we can see that we are using the environ function. Environ in Python is a mapping object that represents the user environment variable. Like here is the db password is the environment variable. Similarly, here is another environment variable, AWS Lambda function name. Here AWS Lambda function is contacting with the KMS to decrypt the data. Encryption context. It is a key value pair of additional data that we want to associate with the AWS KMS protected information. So this is the information, and here we are decoding a UTF-8 encoded byte string that will return a corresponding Unicode string. And here we have set the content type as plain text. So this decrypted value will store a plain text value. And this function will return the decrypted value. So now let us execute this code. For executing, we have to configure a test event. Simply we have to name it, we will give it a name as demo KMS lambda, and we'll create it. And now we can run this code. As we can see, there is some error regarding the timeout, so we will increase the time duration. In going to the configuration, in the general configuration, we'll edit, and let's say keep it to 15 and save. Now again we will test it. Now again there is some error regarding the cipher text refers to a customer key that does not exist. So this is the error. So why is this error? That if we see in the code, here we can see that we are using a decrypt call from AWS, but the lambda function is not being authorized to make a decrypt call. So for this we have to modify the IAM role permission. Going to the execution rule, and here we will add inline policy. Inline policies are the policies that we can create and manage and embed directly into the rule. So here I will choose a service KMS, and we have to specify the action that will be allowed, that is decrypt action. Decrypt action is allowed. In resources we have to specify the ARN of the key. So I will go to the KMS service. In the demo KMS, I will copy this ARN. Going back to the IAM console management, and here I will paste this key and add it. Click on review policy and can give the name to this policy as KMS decrypt. Click on create policy. Now the policy has been attached. I'm going back to the code. This time we will again test it. Here we can see that our test event, that is demo KMS Lambda, responds with the super secret. This is the same value that we have given to the DB password key pair. Like this is the password that we encrypt. That's all. Thank you.